Welcome to Unit 6, entitled Temperature and Heat. In this unit, we're going to be focusing on section 6.1, entitled Definition of Temperature and Heat. Now, before we go into detail in terms of looking at the definition of temperature and heat, it's important to know what the learning objectives are for this section, and they are as follows. After completing this subunit, you should be able to know what temperature is and also understand the difference between temperature and heat. So let's begin now by looking at a definition of temperature. Now, in order to understand temperature and its definition, we need to really look at the four states of matter. And these four states of matter, these are states that you observe in everyday life, and these are solid, liquid, gases, and also plasma to some extent. So when we talk about a substance, we're really talking about a material which is made up of small particles, and these particles are called atoms and molecules. And any type of substance can exist in one of four distinct forms, which we call states of matter. Now, the four states of matter which are observable in everyday life, these are solids, liquids, gases, and to some extent, plasma. Now, any type of substance can be found in these states, and if we look at the diagram, we can see that the particles in a solid state, they tend to be fixed in terms of their relative positions, but they tend to vibrate backwards and forwards about a fixed point. Whereas the particles in a liquid and in a gas, they tend to be always in motion. And so when a substance is made hotter, the speed of the particles increases and they gain what's called kinetic energy. Now, when we talk about temperature, we're really talking about the hotness or the coldness of an object. And this is due to the average kinetic energy of the particles. In other words, the particles within that substance, as they move around with motion in all directions, they're going to have kinetic energy. So really, when we measure the temperature of a substance, we're actually measuring the average kinetic energy of the particles in that substance. Now, the temperature of a substance does not depend on the size or the type of the substance. So it doesn't matter whether you measure the temperature of water in a big cup or in a small cup. It's basically independent. The measurement of temperature is independent of the size or the type of the material. Now, temperature is intensive. So temperature is intensive in the same way as pressure or density. For example, the temperature of a small cup of boiling water is the same as the temperature of a large pot of boiling water. So we refer to the fact that temperature is independent of the size or the amount of the water that's being measured. We refer to that as the intensive nature of temperature. So temperature is an intensive property, and it doesn't depend on the amount of the substance present. And this is very important that you understand that, especially as we go through the unit on temperature. And so temperature is measured with a thermometer, and temperature is the measure of the hotness or the coldness of matter. And the SI unit of temperature is Kelvin. Now, in terms of a definition of heat, heat is the total energy of molecular motion in a substance. So it's the total amount of energy of all of the motion which is going on inside of a substance. And heat depends on the size and also the type of the material or substance. So we can say that heat is an extensive property because unlike temperature, heat does depend on the nature and the magnitude, the size of the substance. So, because it depends on the amount and the size of the particles in the substance, heat is the form of energy that is transferred between two substances at different temperature. So if you had to give a definition of heat, what you could basically say is that heat, usually given the symbol Q, is the total kinetic energy of all the particles in the substance. It is an extensive property which depends on the size and the type of the substance, and its unit of measurement is the joule, which is given as J. Let's have a look at some checkpoint questions. The first checkpoint question is, explain the term temperature. The second checkpoint question is, describe the difference between temperature and heat. And the third checkpoint question is, how can we relate the temperature of a body with the kinetic energy of its particle? Fourth checkpoint question is, temperature is an intensive property of a body, while heat is an extensive quantity. Explain what this means. So these are your 4 checkpoint questions. So pause the video and open your exercise book and write down your answer to these specific checkpoint questions. And then when you've written down your answers, then press the play button to compare your answers with the answers provided in the solution. Okay, let's have a look at the answer to these checkpoint questions. So, question number 1 was explain the term temperature. There is a measure of the average heat or thermal energy of the particles in a substance. The second checkpoint question was describe the difference between temperature and heat. Well, what you should have written was something along the lines of temperature is an average measurement of kinetic energy of the particles in a substance. And temperature does not depend on the number of the particles in the substance, while heat is the total kinetic energy of the particles in a substance, and heat depends on the type and the size of the substance. Now at checkpoint question 3, how can we relate the temperature of a body with the kinetic energy of its particle? The answer to that would be along the lines of, when the substance is made hotter, the average kinetic energy of the particles in the substance will increase. Therefore, the average kinetic energy of the particles in the substance is in fact directly proportional to the temperature of the substance. And then the fourth checkpoint question was, temperature is an intensive property of a body, while heat is an extensive quantity. Explain what this means. Well, what you should have written for this is something along the lines of, an intensive property is a physical quantity whose value does not depend on the amount of the substance for which it is measured. So, for example, the temperature of a substance in thermal equilibrium with another substance has the same temperature of the other substance. So if you place a substance next to another substance and you leave them for a while and you measure their temperatures, the temperature of both of these substances, which are side by side and touching each other, is going to be the same. While when we think about extensive properties, for example, mass and volume, then in these particular cases, if we look at the heat heat is going to be dependent on the mass and the volume which is being measured. So this is the difference between temperature and heat. Temperature has intensive property and heat has extensive property. So it's very important that you know the difference between temperature and heat, because a lot of students do tend to confuse the two and mix up their definitions and their meanings. So hopefully you have understood from these checkpoint questions what the difference is between temperature and heat, and now we can move on to the second section within this particular unit, which is section 6.2. Welcome to Unit 6, entitled Temperature and Heat. In this unit, we're going to focus on the section 6.2, entitled Measuring Temperature. Before we look at the section in some detail, it's important for you to know the learning objectives for this particular section. So in this section, students will be able to define what temperature is. They will know the different types of thermometers, and they will understand the applications of thermometers, and they will understand temperature scale. So let's start off by looking at what is a thermometer. So a thermometer is a device that measures temperature or the temperature gradient. And in fact, a thermometer has two very important elements. There is what's called a temperature sensor, which is like the bulb of mercury in a glass thermometer, or the digital sensor in an infrared thermometer. So it's a temperature sensor in which some change occurs with a change in temperature. And so that's the first very important element of a thermometer in terms of having what's called a temperature sensor. And then the second important element is that there has to be some means of converting this change into a numerical value, like the visible scale that is marked on a mercury in glass thermometer, or the digital readout on an infrared model. So thermometers are widely used in technology and industry to monitor processes. And it's also used in meteorology, in medicine, and in scientific research. So here on the right hand side you can see that we have a diagram of a thermometer, and you can see that in this particular glass thermometer we have the bulb, and in this case the bulb contains mercury, and you can see there's a partial vacuum inside the tube which allows the mercury to move up unhindered as the temperature changes. Now, as we mentioned, there are different types of thermometers, and we're going to have a look at the various types of thermometers in some detail. So let's start off by looking at the first one, which is a mercury thermometer. Now, mercury thermometers, they work on the basis of thermal expansion of mercury, and the mercury expands with increased temperature. Clinical thermometers and laboratory thermometers, they are made of mercury, and the clinical thermometer is used by health officials in hospitals and in clinics. Now, the laboratory thermometer is used by scientists for research purposes. Now, the second class of thermometer is the alcohol thermometer, and this is used to measure extremely low temperature, and it ranges from minus 80 degrees Celsius to 100 degrees Celsius. Most of the thermometers that you use in your science laboratories tend to range from 0 degrees Celsius to 100 degrees Celsius. Now, there's another type of thermometer called a thermostat. It's made up of a bimetallic strip and a scale. And the bimetallic strip is made up of two different metals which are bonded or glued together. Now, because the metals expand at different rates, the combined strip bends in a certain direction when it's heated. And when it cools, it bends in the opposite direction. So we use thermostats in refrigerators as a switch. And then the next type of thermometer is the electronic thermometer, which works in an entirely different way to mechanical thermometers. Remember that mechanical thermometers, they use mercury or spinning points. But in the case of electronic thermometers, they are based on the idea that the resistance of a piece of metal changes as the temperature changes. So in other words, as the metal gets hotter, then the atoms inside that metal, they vibrate more inside of the metal. And so it's harder for electricity to flow. And that's because the resistance increases. And so similarly, in metals that cool down, the electrons move more freely and the resistance goes down. So an electronic thermometer works by putting a voltage across a metal probe and measuring how much current flows through it. And then inside of that electronic thermometer, you have a microchip, and that microchip measures the resistance and converts that resistance into a measurement of temperature. And so the main advantage of thermometers like this is that they can give you an instant reading in any temperature scale that you like, Celsius or Fahrenheit, or whatever the temperature scale happens to be. But one of the disadvantages of electronic thermometers is that they measure the temperature from moment to moment. So the numbers they show can fluctuate quite dramatically, sometimes making it very difficult to obtain accurate readings. In the diagram here, you can see that we have each of those four different types of thermometer. Here we have the alcohol thermometer, which is the one that you use a lot in schools. Here we have the mercury thermometer, which is used in sort of clinical environments, hospital environments. Then we have the thermostat, which involves a bimetallic strip, which is used in refrigeration, for example. And then we have the digital thermometer. What are the applications of thermometers? Well, thermometers are required for numerous purposes, and these range from the household use to use in the industrial sector. Now, in the kitchen, the temperature of food can be measured using thermometers. And likewise, in the refrigerator, we can use thermometers to maintain a set temperature in the refrigerator. In the factory, for example, the thermometer in the furnace will enable turning on and turning off of the furnace. So it's very important to choose the right type of thermometer which suits the intended application in terms of what you want to use it for. So in other words, it would be pointless to use, say, a factory thermometer in a furnace in order to measure the temperature of food, because these furnace thermometer is probably calibrated for very high temperature measurements, and so probably wouldn't be very suitable for use, for example, in the kitchen. Have a look at some checkpoint questions related to what we've explored so far. So how can you measure accurately the temperature of a body? And the second checkpoint question is, describe the different types of thermometers. And the third checkpoint question is, explain how a mercury thermometer functions. So draw a diagram of a thermometer and label it. So have a go at these checkpoint questions. I'll give you a few moments to go through them, and then pause the video when you're ready to compare your answer with that of the answer provided in the solution, then press the play button. Let's have a look at the first checkpoint question. How can you measure accurately the temperature of a body? And you do that using a thermometer. So that's quite a simple question in terms of just knowing that you can measure temperature of anything, of any body or any substance using a thermometer. So the second checkpoint question is describe the different types of thermometers. Well, we have, for example, mercury thermometers, and we also have, for example, alcohol thermometers. So those would be two of the more familiar thermometers that you would probably use in your school or even at home, or even possibly in, for example, a medical setting, a clinical hospital environment. The final checkpoint question here was explain how a mercury thermometer functions, and then draw a diagram of the thermometer and label it. Well, a mercury thermometer operates by contraction and expansion of the mercury or the alcohol in the bowl. So as the temperature increases, what happens is that the mercury or alcohol in the bowl will begin to expand. And so what you'll see in terms of the thermometer is that the liquid appears to be expanding and moving as the temperature increases. And similarly, in terms of when the temperature begins to decrease, then you will see contraction. In other words, the liquid in the thermometer, whether it's mercury or the alcohol, will literally seem to be decreasing in terms of its length due to contraction. In this section of the unit, we're going to focus on subsection 6.3, entitled Temperature Scale. Students will be expected to read a thermometer. So let's begin by looking at how you would make a thermometer. In order to make a thermometer, you need to have two fixed points of temperatures of the body that you're taking the temperature of. So in order to make a thermometer, you need to identify two fixed points on the thermometer which relates to the temperature of the body. And this must be marked on a thermometer scale board. So the distance between the two fixed points, they must be divided by sections of equal lengths. And these two fixed points, they are the lower fixed point, which would, in the case of ice or water, this would represent the melting point of ice. In other words, ice melts at a temperature of 0 degrees Celsius. And you could also have an upper fixed point, which would represent the boiling point of water at sea level, and that would be 100 degrees Celsius, which is the temperature that the water will boil. Essentially what you're doing is that you're marking out the fixed points of temperatures relating to the temperature at which water freezes, so that will be identified as the lower fixed point or the melting point of ice, and you would mark that out on a card, and then you'd have the upper fixed point, which is the temperature at which the water boils, and so you'd mark that out also on a card. So the three common temperature scales are the Celsius scale, which is 0 degrees in terms of the lower fixed point, and 100 degrees, which is the upper fixed point. And then for the Fahrenheit scale, you have the lower fixed point of 32 degrees Fahrenheit and the upper fixed point of 212 degrees Fahrenheit. And for the Kelvin scale, you have the lower fixed point of 273 degrees and the upper fixed point of 373 degrees for the Kelvin scale. What you would do now, if you look at the diagram, is you just put these all side by side And so in the diagram, what you would have is for the corresponding upper fixed point for the Celsius thermometer, which is 100 degrees Celsius, that corresponds to the upper fixed point of 373 Kelvin for the Kelvin thermometer and 212 degrees Fahrenheit for the Fahrenheit thermometer. And in terms of the corresponding lower fixed point for 0 degrees for the Celsius thermometer, that would correspond to 273 Kelvin for the Kelvin thermometer and 32 degrees Fahrenheit for the Fahrenheit thermometer. And you can see here that as we go below 0 degrees Celsius, we can show the corresponding points for various temperatures in degrees Celsius in terms of how they relate to temperatures in Kelvin and temperatures in Fahrenheit. So how do you read a thermometer? So to read a thermometer is quite straightforward. For example, if we have this diagram representing the temperature scale in Celsius, in other words, the Celsius thermometer, all you would do is to determine the reading, for example, at this point here, you would just look at the corresponding value for the temperature in Celsius as it corresponds to the level of the actual liquid inside the thermometer. So here you can see that this would represent 50 degrees Celsius. This area here would represent 20 degrees Celsius, and this would represent 0 degrees Celsius. So that's how you would read a thermometer, just aligning your eyes along the level of the liquid in the thermometer and then looking at the corresponding value in terms of the reading in degrees Celsius. In order to convert temperature scales from, for example, Fahrenheit to Celsius or Celsius to Fahrenheit or even Celsius to Kelvin, we can use a series of conversion expressions. So for example, if we wanted to determine the temperature of a substance in Fahrenheit, but we know its temperature in degrees Celsius, we can use the expression that F is equal to 9 divided by 5 multiplied by the temperature in Celsius plus 32. So that expression would give us the temperature in Fahrenheit. And if we wanted to determine the temperature in Celsius, and we know the temperature in Fahrenheit, we can say that the temperature in Celsius is equal to 5 over 9 multiplied by, and we have a bracket, the temperature in Fahrenheit minus 32, close bracket. And if we wanted to determine the temperature in Kelvin, and we know the temperature in degrees Celsius, we can use the expression that the temperature in Kelvin is equal to the temperature in Celsius plus 273. So these are the typical conversion scales for temperature in terms of Fahrenheit, Celsius, and Kelvin. And you're going to be using these in the following worked examples. So let's have a look at the first worked example. The temperature of a body is measured as 50 degrees Celsius. Find out the temperature of the body in Fahrenheit and Kelvin. So let's go through this one together. You're given that the temperature in degrees Celsius is 50 degrees Celsius. And you're required to find F, the temperature in Fahrenheit, and you're required to find K, the temperature in Kelvin. So what we would do to determine the temperature in Fahrenheit is to use the expression F is equal to 9 divided by 5 multiplied by the temperature in degrees Celsius plus 32. And if we substitute in the values for the temperature in Celsius, which is 50, into the expression, we get that the temperature in Fahrenheit is equal to 9 over 5 times 50 plus 32, and that will give us a value for the temperature in Fahrenheit of 122 degrees Fahrenheit. And similarly, if we wanted to determine the temperature in Kelvin, we would use the expression that K is equal to C, which is the temperature in degrees Celsius, plus 273. And the temperature in Celsius is equal to 50 degrees. Therefore, the temperature in Kelvin is equal to 50 plus 273, and that will give us a value for the temperature in Kelvin of 323 degrees Kelvin. So let's consider another worked example. Convert 200 degrees Fahrenheit into Celsius and Kelvin. So we're given that degrees Fahrenheit is equal to 50, and we're required to determine the temperature in Celsius and also in degrees. So to determine the temperature in degrees Celsius, we just use the expression that the temperature C in degrees Celsius is equal to 5/9, and then we have bracket the temperature in Fahrenheit minus 32 close bracket. And if we do that, we get that the temperature in degrees Celsius is equal to 5/9 multiplied by 50, and that's in bracket, minus 32 in the close bracket. That will give us a value for the temperature in degrees Celsius as being equal to 15 degrees. And similarly, we can work out the temperature in Kelvin by using the expression that the temperature in Kelvin is equal to the temperature in degrees Celsius plus 273. Well, we've just determined what the temperature is in degrees Celsius. That is 15. So we can then add 15 to 273, and that will give us the answer for the temperature in Kelvin as 288.